Hi, welcome to my channel pibyme Maths. This is by WST02. Here we are solving October-November 2023 Statistics 2 paper. So in the previous video we have covered question number 1 to 4. Let's look at question number 5. A supermarket receives complaint at a mean rate of 6 per week. Okay. State one assumption necessary in order for a Pearson distribution to be used to model the number of complaints received by the supermarket. So the complaints are independent of each other and then they are happening at a constant rate. So you can write complaints received are independent and occurring at a constant rate. Constant rate or occurring singly. So you can just write these 2 points. That's enough for 1 mark. Part B. Find the probability that in a given week there are fewer than 3 complaints. Okay, first of all we are going to define the distribution per Pearson of 6 per week. That's what they say, right? Mean rate of 6 per week. Now they want us to find fewer than 3, which is same as less than or equal to 2, double I, at least 6, so greater than or equal to 6, which is 1 minus less than 6 or less than or equal to 5. So I'm going to use the table value for lambda is equal to 6, x is 3 and 5. Okay, the lambda value is 6, x value is 3, you will get 0. X value is 6. So x is less than or equal to 2. So it's 0.0620. This is 0.0620. Here 1 minus, for x is equal to 5, the corresponding value is 4457. 0.4457, so it's going to be 0.5543. That's all. Part C now. In a randomly selected week, the supermarket received 12 complaints. Okay, that's the observed value. Test at the 5% significant level whether or not there is evidence that the mean number of complaints is greater than 6. State your hypothesis. The null hypothesis is mean is 6. Alternative hypothesis is mean is greater than 6. So if it is greater than 6, that's upper tail test, right? So we have to test p of x is greater than or equal to the observed value. I'm using the method 1 because we have observed value, which is same as 1 minus p of x is less than 12 or less than or equal to 11. So for lambda is equal to 6, I'm going to look at the value for x is equal to 11. X is equal to 11, it's 9799. So 0.91 minus 0.9799, when you subtract from 1, it's 0.201. That's smaller than the significant level. If it's smaller than the significant level, we reject H0. So if we reject H0, we are going to accept H1. So you cannot just write reject H0. You need to write what does that mean, accepting H1. What does accepting H1 means in this context? H1 is this, that the mean is greater. So that you need to write there is sufficient evidence. There is sufficient evidence to suggest that the mean number of complaints is greater than 6 per week. You need to write this. That's the conclusion. If you don't write this, you will lose more. Here the method I have used is the method 1. In method 2, you can find the critical region and then check whether 12 is in the critical region or not. Part D now. following changes made by the supermarket. It received 26 complaints over a 6-week period. There were 6 complaints per week, so 6 weeks it's supposed to be 36, but they received 26 complaints. Use a suitable approximation to test whether or not there is evidence that the following the changes, the mean number of complaints received is less than 6. You should state your hypothesis clearly. The null hypothesis is 6 per week, or you can write 36 also. Both are correct. The alternative hypothesis is less than 6, or you can write less than 36. Both are correct. Okay. Now we are going to use a suitable approximation. First you write x follows Poisson distribution of 36. So that implies when you apply the approximation, n follows lambda comma lambda, where mu is equal to 36. Sigma is square root of 36, which is 6. So since 26 is the observed value and it's a lower tail test, you need to find p of x is less than or equal to 26. Apply the continuity correction, which is p of x is less than 26.5. Standardize the normal distribution. 26.5 minus mu over sigma. Z is less than. So let's find this value first. 26.5 minus 36 over 6. Change it to 2 decimal place. P of minus Z is less than, Z is less than minus 1.58, which is same as 1.58, right? Yeah, 2 decimal place. 1 minus P of Z is less than positive 1.58. So let's get the table value for 1.58 and subtract from 1. So we need to find this. Now 1 minus, let's get the table value for 1.58. For 1.58, the table value is 9429. 0.9429. When you subtract from 1, it's 0.0571. What is the significant level? 5%. It's bigger than 5%. If it's bigger than 5%, we do not reject H0. That means we are going to accept this, we reject this. So how do we write this? We need to write that there is insufficient evidence to suggest that the compliance has decreased less than 6 per week. So you need to write, therefore there is insufficient evidence to suggest that the mean number of complaints received is less than per week. You need to write this. That's all. You don't write the conclusion, you will lose a mark. Question number 6 now. We have a cumulative distribution, capital F of y is given. Find this conditional probability. We are going to apply the formula for conditional probability by taking it is A given B. It's A intersection B, that is P of y is less than 1 over k, which is k over 4, intersection y is less than k, divided by P of y is less than k. The intersection of these two, if you put it on a number line, it's 0, k over 4, k, less than k over 4. The intersection is basically less than k over 4, right? That's the intersection. So it's P of y is less than k over 4 divided by P of y is less than k. P of y is less than k over 4 is same as f of k over 4, because we know the formula for cumulative. F of x is P of x is less than or equal to x. So whether there is a equal sign or not, it's a continuous random variable. So you can write this as f of k now. Okay. So k over 4 is in here middle. So you need to sub in k over 4 here. So that's going to be 1 over 21 k over 4 whole square divided by f of k. F of k, k is also here, that is an equal sign, right? So sub in k here. So you will get 1 over 21 k square. The 1 over 21 k square will be cancelled. You will get 1 over 16. That's just a 2-mark question. Part B, I have copied the function, cumulative function here. Find the value of k. You see, when k, y takes k, you can use this function. When y takes k, you can use this function. Both the value of the function will be same. So I'm going to sub in k into the first one. 1 over 21 k square is equal to, sub in k into the second one. So it's going to be 2 over 15, 6k minus k square over 2 minus 7 over 5. Find the value of k. Definitely k should be a positive number. Okay. How are we going to simplify this? Okay, maybe open the bracket. K square over 21 is 12 over 15, which is 4 3s are 12, 5 3s are 15, minus, when you multiply this 2 will be cancelled, k square over 15 minus 7 over 5. Okay, now let's multiply through it by 15. 15 over 25. 5 3s are 15, 7 3s are 21. K square. 5 3s are 15, 12k minus k square. 5 3s are 15, 5 7s are 21. And then multiply through it by 7. You will get 5k square is equal to 784k minus 7k square. Minus 147. Move everything one side. You're gonna get 12k square minus 84k plus 147 is 0. You can divide through it by 3, I guess. 4k square, 84 divided by 3. 2 3s are 6 divided to 24. 8 3s are 24. Plus 4 3s are 12, remainder to 27, 9 3s. We got a quadratic equation. Let's solve this quadratic. 4 minus 28, 49. Okay. 7 over 2. Just 7 over 2. Its axis k is equal to 7 over 2. Or 2k minus 7 whole square is 0. So that's the final answer. K is 7 over 2. 7 over 2 is 3.5, which is smaller than 6, right? That's all. It's a 4-mark question. Part C is a 6-mark question. Find E of y. To find E of y, the formula is y times f of y PD of dx. So we need to find the PDF first. So we have to differentiate the functions one by one. Sorry, not this one, this two. So you can write f of y is equal to, when you differentiate this one, 2y over 21. You can write it here, 2y over 21. When you differentiate this, 2 over 15 times 6 minus 2y over 2, 6 minus y. And then 0 otherwise. That's how we write small f of x, right? This is 0 to, don't put k, k is 7 over 2. And then 7 over 2 is less than y, less than or equal to 6. We got small f of y already. Now we use the formula. E of y is integral 0 to 7 over 2 y times f of y, which is 2y over 21 dy. Plus integral 7 over 2 to 6, the second function, y times f of y, 2 over 15, 6 minus y dy. We need to integrate and sub in the values, upper limit, lower limit. We will get the value of E of y. So first I'm going to write it as 2 over 21 integral y square dy plus 2 over 15 integral 6y when you open the bracket dy. The limit is 6, 7 over 2, 0 to 7 over 2. Now we integrate it 2 over 21 y cube over 3, 0 to 7 over 2, or 3.5, plus 2 over 15, 6y square over 2, which is 3y square, minus y cube over 3, that's 3.5 to 6. We need to sub in the limits now. So when you sub in the limit, upper limit 3.5, you're going to get 2 over 21 times 3.5 cube over 3, 49 over 36, plus here 2 over 15 times, sub in the upper limit first. When you sub in the upper limit in the place of y, 3y square, upper limit is 6, minus y cube over 3, that's upper limit, you will get 36, minus, let's sub in the lower limit 3.5 in the place of 6, 3y square minus y cube over 3, get 539 over 24, simplify everything now, 49 over 36 plus 2 over 15 times 36 minus 539 over 24, close the bracket. The answer is 19 over 6 is the value of E of y. That's all. Let's look at question number 7 now. The discrete random variable x is given by this. X follows binomial distribution of n, p, where the value of n, value of p are such that x can be approximated by a normal variable y, where y is this. Given that when using normal approximation, p of x is less than 86 is this, p of x is less than 97 is this, find the value of sigma. We are going to frame two equations in terms of mu and sigma and solve the simultaneous equation. Okay, I have taken just the two equations. The first one, you can write it as, apply the continuity correction, x is less than or equal to 85.5 is equal to 0.2266. Standardize this. 85x z is less than or equal to 85.5 minus mu over sigma is 0.2266. I'm going to do the same thing for the next equation. Apply continuity correction. X is greater than 9, which is greater than or equal to 97.5 is 0.1056. Standardize the normal distribution. 97.5 minus mu over sigma is 0.1056. Now before we use the table, we need to find out whether these values are positive or negative. How do we find out? Okay, if you take the bell curve, mu is in the middle. Okay, when they say z is less than or equal to, they are talking about the area on the left hand side of this point, and the value is smaller than 0.5. We know this is 0.5, this is 0.5. So where the value lies, so that the left hand side area is less than 0.5, definitely the value should be here, so that this area is less than 0.5. Mu is 0, less than 0.5, right? So it's a negative number. Okay, it's a negative number, so you can't just blindly use the table. For negative number, you can change it to positive. This area, you can write this area as P of z is greater than or equal to the area on the right hand side of a positive number. How do you change it to positive number? Write it as mu minus this. Okay. If the black area is 0.2266, what would be the area on the left hand side of the positive number? 1 minus this answer, right? 1 minus this, right? Which is 0.7734. Okay, now here we are going to use the table now. Later we will use the table. Let's go to the second equation. Z is greater than, that means area on the right hand side is smaller than 0.5. So definitely it has to be a positive number, right? So if the area on the right hand side is this, what would be the area on the left hand side? One minus this value, which is 0.8944. We got two equations. We need to use the table to find these values now corresponding to the values of phi of z. That's what we are going to do now. So the first equation and the second equation. In the exam, you don't need to write it side by side. You can finish off with the first equation, then write the second one. I'm going to open the table now. Look for the value 7734 first. 7734 is here. The corresponding value is 0.75. So this is equal to 0.75. Bring the sigma here and move it to this side to frame the equation. You will get mu minus 0.75. Sigma is 85.5. Take it as equation 1. And look for the value 8944. 8944 is here, 1.25. So here 97.5 minus mu over sigma is 1.25. Bring the sigma here and rearrange and frame the equation. You will get mu plus 1.25. Sigma is 97.5. That's equation 2. We need to solve the simultaneous equations and then find the value. Show that sigma is 6. It's a 7-mark question actually. Okay. So what I'm going to do, I'm going to do equation 2 minus 1. So the mu will be cancelled. 1.25 plus 0.75, which is 2. Sigma is, so 97.5 minus 85.5, which is going to be 12. Therefore, sigma is equal to 6. Do we need to find mu for this question? You don't have to find mu. Just find sigma, that's all. Part B of the question. Hence, find the value of n and p. We know mu is equal to np. Sigma is equal to square root of npq, right? Or np times 1 minus p. That's a formula, right? So we are going to find mu first. We know sigma is 6. Sub in into any one of the equation. I'm going to sub in into the second equation. From second equation, when your sigma is equal to 6, second equation becomes mu plus 1.25 times sigma is 97.5. Make mu as a subject. 97.5 minus 1.25 times 6 is 90. Okay, so sub in here. So np is equal to 90, and sub in here 6 is equal to square root of np, which is 90 times 1 minus p. Square both sides. 90 times 1 minus p is 36. 1 minus p is 36 over 90. 2 over 5. That gives us P is 1 minus 2 over 5 is 3 over 5. Sub in P here. So P is 3 over 5. So N times 3 over 5 is 90. N is equal to 90 times 5 over 3. 150 is the answer. These two are the answers. That's all.